Hi Advanced Maths, I'm going to show you how to derive the gradient function of any graph from first principles. Okay, now here's my little function over here, y equals x squared I'm going to start with. Okay, now for y equals x squared, I could choose any point on my graph and I'm going to know what, if I know my x value, I'm going to know what my y value is going to be. If I chose the point here, it would be the x value 1, y value 1. Here, x value 2, y value 4. Okay, so I know any point. I could estimate the gradient by choosing 2 points that are very, very, very close together, and that would give me the gradient at this point. Okay, so say if I did the point 1 and 1 and the point 1.001 and whatever that y value is, 1.001 squared. Okay, if I did that, I could find the gradient, or the gradient of the tangent, very close to what the tangent is at that point there. Alright, but that's going to take me a long time to work out the gradient for any different point. What if I want to do it a much simpler way to find out the gradient function of this y equals x squared? Why don't I choose the point x1 and another point x plus x1 plus h. So I'm going on h a bit further along. So here we go, xh, which, you know, if h was 1, it would be this point here. Okay, if x1 was my point, then in terms of x, my y point is going to be x1 squared. And over here, my y point is going to be x1 plus h squared. Okay, so these are my two points, x1 and x1 squared, x plus h and x plus h all squared. Okay, so I can use my gradient formula, which I know very well, is y2 minus y1 over x2 minus x1. That's going to equal the gradient. So let's use these points to find out what my gradient is in terms of x and h. Okay, so it's going to be x plus h squared minus x1 squared. I'm just going to make that an x, okay? Because they're all x plus 1s, it doesn't really matter. Okay, now on the bottom, it's going to be x plus h minus x. Okay, so this is going to be the gradient of my curve of whatever h is. It could be this big, it could be that big, it could be this big, it could be negative. Doesn't really matter. Okay, which is going to equal, if I expand this out, x squared plus 2xh plus h squared minus x squared. These x cancel out, so on the bottom I just get an h. Okay, and that's going to equal, because those two x squareds cancel out, 2xh plus h squared over h. Okay, and that's going to equal h outside of 2x plus h over h. Okay, now what if my h was getting very, very small? So small, what if my h equaled 1? Okay, like it was up here. Okay, if my h equaled 1, then my gradient would be h, which is 1 over 1 plus 1, so it would be 2x plus 1. Okay, but that is quite a far distance. What if I made this point very, very, very small? What if I made this as h approaches 0? I could kind of make h equal 0, except that there's an h on the bottom, and that would make it infinity. Okay, it would make it undefined because I can't have a 0 on the bottom. But I could do as h approaches 0. As h approaches 0, we're going to get 0 over 0, which is 0, okay, cancels it. We're going to get h outside of 2x plus h over h. As it approaches 0, I can cancel these out. That's how we do limits. Hopefully remember that from when we did limits earlier. 2x plus h, which is 2x plus 0, which just equals 2x. Okay, so for any point x1, as h approaches 0, the gradient is going to become 2x. What if I were to make my x1 point be 1? Okay, then I can put my 1 here, and that's going to translate all these to 1s, and it's going to become, when x equals 1, the gradient is going to be 2 times 1, which is going to be 2. So for this, whatever I put in, 1, 2, 3, 5, that 2x is going to be able to determine what my gradient is. So this is from first principles. Okay, and you can do this with anything. You could do this with y equals 3x cubed minus 2x plus 7, okay? And we can choose 2 points. Point 1 is x, and then the next point is going to be 3x cubed minus 2x plus 7. And then we're going to have x plus h, okay? And the next one is going to be 3x plus h cubed minus 2x plus h plus 7, okay? And then we find, once again, using our gradient formula, gradient, and then we're going to find out what our gradient function is going to be as h approaches 0. Hopefully, that makes a little bit of sense of how we do calculus from first principles.